All right, this is the first kind of half of the fundamental constants here. Notice, I think in all my videos I use 9.81. Now they're finally saying, hey, just use 9.8. That's close enough. This is the fundamental constant from force of gravity is G m1 m2 over r squared. This is Avogadro's number. I'm not going to call it avocado's number. That's how many particles there are in a mole. Right? So if you have half a mole, you've got 3.01 times 10 to the 23rd, right? This is our gas constant in PV equals nRT. This is the Boltzmann constant, right? And so just be careful. It really is the only physics constant with a K in it. I'll explain that in a second here, right? Stefan Boltzmann, this is for radiative power output. You'll see this in the greenhouse gas one. And then this is the Coulomb constant. I'll put quotes around it. But this K, this guy here is actually equal to 1 over 4 pi epsilon naught. Okay. Just lest you think it's not really, I don't know, it's handy. Okay. You don't have to do all that work, right? Okay. This is the permittivity of free space. The permeability was really close to 4 pi times 10 to the minus 7th, right? So they just, they defined it to be that, and then they changed everything else, right? So that worked. This is the speed of light with 3 sig figs. There it is, right? Okay. Yeah. All right. And then there's Planck's constant, right? Which by the way, mass is now defined in terms of Planck's constant, the fundamental definition of mass. This is the charge, the elementary charge. So this is electrons have negative this charge, protons and anything with a plus, right, is positive that. Here's the electron rest mass, which is given in kilograms. It's given in unified mass units. And then it's given in millions of electron volts, which is interesting, right? Which that's an energy unit, right? So try this, right? E equals mc squared. Take that mass and plug it in there. Speed of light there, right? And you're going to get something in joules, right? And then convert that to electron volts and see if you get 0.511 MeV. I bet you do, right? That's what they're saying. So that's the energy. This is the energy equivalent, right? A proton, to create it from pure energy, would take that much energy. This is how much energy to create a neutron, right? And then one unified mass unit has the energy equivalent of 931 MeV. And you're going to use this all the time, right? In a nuclear reaction, if the reaction lost mass, then it was giving off energy, right? It turned mass into energy. And if it gained mass, it got the mass from the energy, right? This is the solar constant. I'm going to put that in quotes, right? Okay. So 1 square meter of real estate on the Earth's surface, 1 meter, right, is going to be 1,360 watts. Right? But that's, on a clear day, that depends on the sunspot, where you are in the sunspot cycles, because the sun gets a little brighter when there's sunspots, which is weird. But I think that's what happens, right? And then this is the Fermi radius, right? So that's the radius of a hydrogen atom, right? Or a hydrogen nucleus. And remember that atoms are about 10 to the minus 10th meters. So an atom is about that big. The nucleus is on the order of 10 to the minus 15th meters, which means you can't really draw a picture of an atom, right? And if you can see the atom, right, the nucleus is too small to be seen, right? Yeah, I think there's nothing else to say about that.